guys will be able to see me, and if not, at least to hear what I'm going to say. And just a bit about myself. I'm Itiel Shwartz, co-founder, CTO of Commodore. I've been working as a backend engineer, DevOps, SRE, platform engineer for the last 10 years. I've been working with Kubernetes over the last 8 years, I would say, maybe 9 already. I co-founded Commodore in order to simplify Kubernetes for our customers. And over the last 2 years, I've been leading our LLM efforts. Basically, how can we take an existing product that helps developers and DevOps to troubleshoot Kubernetes and to bake LLM into it? It's been a very rough experience. And I'm here to share basically what I learned throughout the day. So the goal of this conversation is not to talk about how do I develop in LLM in general or something like that, but to take the things that worked for us in Commodore and to basically explain the things that worked well and the things that didn't work well, and maybe it will help one of you that is trying to build an LLM agent, basically. So I want to start very quickly with the mission, what are we doing in Commodore? So Commodore, in a very, very high level, we simplify Kubernetes for our users. It means that we help them around the troubleshooting aspect, meaning detect, investigate, remediate issues in Kubernetes. And on the other side, we also help them to optimize their cost and their performance. So it's like a dual strategy of everything enterprise needs for Kubernetes. All in all, I think that Kubernetes is quite complicated, and when we founded Commodore, all of the code, everything that we did was very manual. We had huge decision trees across the product, and given a specific set of problems, we were able to help the user to find and determine the root cause. Then, as all of you know, LLM became much more popular. We saw that we ourselves are using LLM much more, and we decided to use LLM in order to simplify or to improve our product and to simplify the life of our users even more. The problem with LLM is that on one side, it sounds very cool, right? And when you do the first demo with LLM, then everything is great. It works, you do the hello world, and everything is perfect. But on the other side, once you try to dig a bit deeper, once you try to build an agentic system that is consuming quite a lot of data, and Kubernetes, for everyone here that doesn't know Kubernetes, it's a container orchestration system, and in a simple Kubernetes cluster, there might be millions of events, hundreds, thousands of different nodes, a lot of workloads. You don't really need to understand all of those terms, but just think about very big and very messy data points. And when you put it inside an LLM, what you're going to get is sometimes magical responses. Using LLM, you're able to understand and to solve issues in Kubernetes quite easily. On the other side, using LLM, you start to see more and more hallucinations because LLM always tries to please you. And when it has a lot of data, it gets simply confused. We saw that on our first tries of using LLM, it didn't really work. Meaning, we got some good responses, we got some horrible responses. And over the last 2 years, what we've done is trying to perfect that, basically, to take the good stuff out of using LLM and to try to minimize the bad stuff, which is mainly hallucinations and bad answers. So I'll cut for a second for the end of the story. We were able to build Claudia. Claudia is an AI SRE for Kubernetes. It means that it tries to mimic and to help SREs running Kubernetes. It basically does, or it tries to do everything a good SRE would do, given a Kubernetes problem. And if we started our journey with something very naive, which helps you to solve problems in unhealthy pods in Kubernetes, we are now expanding it to a lot of different use cases. So that means detection, investigation, remediation, chat, and so on and so on. But I'll cover that more going forward. So the first thing that you do when you are starting to build your own LLM, you need to define some sort of North Star. I think it's true for every project. It's even more true when it comes to using LLM. And again, I'll be honest here, and I'll say the unpopular opinion that when Commodore started this journey 2 years ago, I was very skeptical. I think that everyone here who have done DevOps or SRE for a lot of time heard the term AIOps for years over years. Most of the time, this term, this technology, oversold and under-delivered. It means that there were a lot of really good promises, but in the end, as a user, as a consumer of those systems, I felt that it's like, in best case, a glorified regex system. In worst case, it simply created a lot of noise for us. And I really wanted to build a product that works, that helps customers to simplify their life when using Kubernetes. So this leads us to the quality framework. The quality framework is how Commodore built Cloud. And again, even we're talking here about Kubernetes and being an AI SRE, I think it's like you can use this pattern no matter what LLM you guys are building. And the first thing first, like we try to ask ourselves, like, what do we want to do? What do we want to achieve here? So we wanted to be as good as a senior SRE. That's our goal. That is still our goal in Commodore when building new features. But more importantly, for us, the main thing was to do no harm. That basically means that when Commodore is saying something, we wanted to be not bad. What does it mean? It means, for example, that we won't recommend stuff that can be destructive. I don't know, delete this namespace, delete this cluster, or something like that. On the other side, it was very, very important for us that our offering won't sound completely, I don't know, like doesn't make any sense to our users. And I can give an example from one of our users that was a beta tester of the Commodore Cloudian SRE. And he was still an early beta tester back then, and he really loves the product, he loves Commodore, and then he sends me a usage example of Cloudia, and he tells me, Itiel, like you got it all wrong, like the response here doesn't make sense. And I'm reading what Cloudia told him to do, which is like a problem with some Azure network problem, and Azure has a lot of issues, so I thought, okay, like that makes sense. To me, it looks like a really good recommendation. But then he tells me, hey, I'm on AWS, you are blaming Azure, I'm sure that's not the problem. And the reason for that is because LLM always try to be very, very pleasing. It means that LLM don't like to say something like, hey, I don't know, I can't help you, I have no idea what's the problem here. And what we did in Commodore is we tried to put a lot of different guardrails. So if the LLM doesn't really know what it is saying, it's still able to say, hey, I have no idea what's the problem here. Go figure it out by yourself. And we believe that it's better than to give something that is simply not true. Secondly is our own precision. So first of all, like we do no harm. We try never to lie. We try never to do something that is destructive. Then we wanted the precision. And for us, the way to get precision, and again, I think it's true for most LLM-based agent, is to reduce its scope. So Kubernetes is very complicated. It has a lot of moving pieces. There are nodes and pods and network layer and storage layer and ingresses and Istio and threat manager and external DNS, and there are a lot of moving pieces that might go wrong. And when we started Cloudia, there was a question, where do we start? Do we want to tackle everything? Do we want to find something in particular to start? And overall, I think the first 6 months of Cloudia, like working on Cloudia, we set ourselves on a very small task, and it's not really that small, but only pods that are unhealthy. That means that if your node was unhealthy, I didn't help you. If you had a problem even with your deployment, I didn't help you. If you have a problem with anything which is not an unhealthy pod, we simply didn't trigger Cloudia, we simply didn't work on that. That is because we really wanted to be especially good in that use case. I think it was a really good decision, because once we make pod investigation to work, then all of the rest follow. And thirdly is the coverage, right? Okay, so we're very good in solving issues around pods, but our users has a lot of other issues or problems. And we added more use cases, meaning more resources or more use cases for Cloudia, only after we felt confidence enough in the use cases that we already had. So we talked, how do I go forward? No? Okay, so we understand that we want to be with the super high quality, right? And that's the most important thing. And I'm telling you that without precision, your LLM won't really work. But how do I get there? So the first thing that I will say, and again, it sounds a bit naive. We're getting back to old school engineering, which is local development. For LLM, the main problem that we still have to this day is that it can be very chaotic. I have no idea what a change in the prompt is going to do to the actual usage, meaning I can change a single line that I don't think it is that important, then all of a sudden the answers are not going to be good. For us in Cloudia, it was crucial to be able to work locally in order to work much faster. Secondly, is more around golden standards. Again, like there's a lot of very fancy terms in the LLM space, but actually it means testing. So we need a very large set of use cases or test cases, and those test cases help us to validate that what we're doing actually works. Shadow agent validation, again, very fancy name for A/B testing, the ability to run multiple agents at the same time. And lastly, LLM as a judge, again, this is a bit, it is like a bit newer, right? Like the ability to use LLM not only to write code, but also to validate itself. But you can think about it as like automating your QA team. The ability to take an LLM and make it be as good as a really good QA when it comes to grading the different LLM outputs. So I'll start with the local development. Yeah, so I'll start with the local development. And what we saw throughout the years of building and doing more and more use cases is for LLM or like for agentic-based development, speed is not a nice to have. It's not something that it's good to have and be faster. It's a must. And we did some like analysis on how much time does it take us to develop a new version, meaning we have Cloudia that it is really good in solving pod issues. We want to add another feature, another capability, maybe to look at config maps or maybe to look at the node or something like that. It is like, sorry? Yeah, it's a minimum of like 50 different iterations before we are able to achieve that. So it means that I'm going to have a lot of trial and errors before I'm able to feel confidence with this new version. If each iteration takes you, I don't know, like 1 or 2 or 3 minutes, it's a lot of time. And in Cloudia, when developing it, we saw a huge difference when it took us to run the test like 5 seconds compared to 20 seconds. A minute sounds to me like, I don't know, I would go crazy. Because every time you are doing the change, you are not sure if it worked or it didn't work. And then you need a lot of feedback loop that allows us to understand it. Other than that, a lot of the times, as always, we write bugs. With LLM, those bugs might be amplified. And that means that you need the ability to do some local troubleshooting, like good old like breakpoint, understand what's happening here, and then figure out what you should do in order to solve the problem. Again, it was crucial for us. Second is more around like the golden standards. Again, you can think about it as a very like fancy name for testing. And that means that we built our own internal playground that allows us to inject or to create a lot of failure scenarios inside of Kubernetes. And that in turn allows us to validate Cloudia faster. So I'm working locally. I have a huge set of different failure scenarios. And then when I'm building a new agent version or when I am adding something, I can validate that it actually works and we don't have any degradation. I think the name of the game here is like degradation. It's very hard to know when LLM is not working as expected because it always tries to please you. Everything that it says does make some sense. So without this ability to run tests on use cases that you validate, that you know what should be the root cause, it's almost impossible to move forward fast. And again, like speed is the name of the game in here. Secondly is shadow agent. Like I told you guys, it's a very fancy name for A/B testing, which means that we want the ability to run our agents simultaneously on real production use cases. Today in Commodore, every time before we release a new version, we have multiple different like experiments that are running at the same time. It means that we're trying different hypotheses. Sometimes we'll say something like, I want to emphasize changes more, or I want to add metrics, or I want to add traces, or I want to add AWS data. And each time, before we are doing this upgrade for all of our customers, we have these very cool shadow agents. What you can see here, like on the right side, that is like a bit yellow, is our LLM as a judge. LLM as a judge is, like I told you, like the very fancy name for automating the QA part. It basically means that we try to bake in how can we grade different sessions? How can we make sure that our analysis is actually good? And for that, we created this LLM as a judge. Building an LLM as a judge for something like Kubernetes is by itself a very, very complicated task. In order to know if the LLM is a judge, like the main thing about LLM is you can never trust them. And you can certainly not trust like your LLM as a judge because he's also an LLM. So we worked really hard on, first of all, trusting our judge, but also have the ability to run multiple judges at the same time. So think about it that you are developing multiple different like shadow flows, shadow agents, that all of them are trying to solve the same root cause. But during that time, you also have multiple judges, right? And those judges grade the success of each one of the sessions. And then it is up for the human to decide which judge is better and then which flow is better. It's a bit like recursive. Maybe we need LLM as a judge for all LLM as a judge, but we are not there yet. The next thing that I want to talk about is that throughout, like I feel like the last couple of years, one of the biggest trends that I see in the industry is that traditional ML is not sexy anymore, right? So if 2, 3, 4 years ago, data scientists were the kings, and we talked a lot about, I don't know, like XGBoost and different like models and so on, then nowadays, if it's not LLM, then it's not sexy enough. That being said, in Commodore, we sometimes found out that the best outcome comes from a combination of both traditional ML and LLM. And one of those examples for us was cascading failure. In Commodore, it was very important for us to help our users when they have a big incident. A big incident might be your database is down, your network layer is not working, you have a problem with Istio, with AWS, and so on and so on. So when something like that happened, basically a lot of different things are starting to break at the same time. When we try to use like only LLM to solve this problem, we simply failed. Like we worked on that for, I don't know, like a month and a half, and all of our responses were really, really bad. And we tried to understand how can we improve it, how can we make sure that this cascading failure capability that was crucial for us from a business standpoint actually works, provide good output without too much hallucinations. And the way that we did it is we started to implement or embed some traditional clustering algorithms to the mix. It means that on the first layer, we take this very noisy word, then we're using some traditional ML, and only then we feed it to the LLM. And then instead of basically trying to throw everything on the LLM, getting very bad responses, we start to get better and better responses. And we simply like separated the logic into very deterministic ML-based flow. And the second one was much more LLM-based. And again, I don't think we should like throw away everything that we've done over the last couple of years just because LLM is so cool. I think a lot of the principles still apply. And more than that, I think that the best companies are the companies that know how to integrate with both of them. So just to conclude everything here, I will conclude everything here. Yeah. So just to conclude everything, like what you should take out of this like talk, or if you are building your own LLM or your own agentic flow in a very complicated environment, what should you do? So my take here is, first of all, trust and precision are the most important things. Like first of all, you need to trust your LLM. And secondly, you need to make sure that it works as expected. I know both from our users and as a user myself of a different system, once I see an LLM lie to me, I won't go and use the same tool again. So it's very, very easy to lose trust. It's very hard to gain the trust back once you did it. I'm a very strong believer that sometimes it's better to be quiet, meaning you don't need to answer every time. Sometimes it's better if your LLM will simply say nothing. I don't know how to help you. I think your users will appreciate it more and you will be happier with the result. The next point is around building local tools in Commodore and validation. In Commodore, I think when we're now developing new flows and new agents, 70 to 80% of our time is not being spent on how do I develop the most cool, sophisticated MCP-based agent. No, it's around how do I validate it. What LLM as a judge I need to build? What other supporting system do I need to build? We build our own internal sandbox, meaning the ability to test everything locally, and we have the ability to run everything. And lastly, maybe like traditional, we talked about traditional LLM and normal LLM. Lastly, I'll say that LLM can be very fun. Like as someone who's done backend engineering for all of his life, I think that over the last couple of years, like leading this LLM journey, it's a different kind of development. I really recommend for anyone who wants to try it. And yeah, that's pretty much it. We have a booth here if you want to hear more about like making your Kubernetes simpler or Commodore, and thank you very much.